We will be discussing about programming in 8085. We'll be basically adding two 8-bit numbers, and there will be a provision of carry as well as storing the result. Now we'll be adding two 8-bit numbers which may or may not generate a carry. Then we will store the result and the carry in two consecutive memory locations. We are storing the numbers to be added in the memory, which will enable us to change the data as and when required without changing the ALP. Now let us assume that the two numbers that we are going to add is stored in the location E000 and E001. Say this is the memory location where we are going to save the numbers that are to be added. The numbers what we are considering here is 49 hex and 50 hex. We are reserving this particular location for sum to store the result, the sum, and if we get a carry, else we will store 00 here. Now these are the locations which I have selected is the user location, that is user programmable locations in the kit that I'm going to use. So it may vary. You'll have to check the location or the programmable locations of your kit. Now let's move on to the flowchart. Well, what we will do is we'll first load 8-bit numbers in the consecutive memory locations. Then we will load the memory address of the first number into the HL pair. Then we will initialize the register B where we will store 00. We will be basically using this register to reflect the carry. Then transfer the content of memory to the accumulator whose address was loaded in HL pair. Now increment the HL pair so that it points to the next location. Then add the content of accumulator, that is an 8-bit number stored in accumulator, and presently the content of the memory pointed by the HL pair. Now check if there is any carry. If we get a carry, then we have to reflect the carry in a register, and that register is B. We will increment that by 1. Then store the content of register B and the content of the accumulator which is actually having the result. And if we don't get a carry, we just have to skip this process and store the content of register B and the content of accumulator into the two consecutive memory locations. We have summed up the entire procedure in steps. The thing that I have mentioned in the flowchart is the same that has been discussed here. Now let's move on to the assembly language program. Now the structure, how we are going to write the ALP is first you write the label which indicates from where we are starting the program or where we are going to come back. The labels will be provided in this column. Then we have mnemonics, then we have memory address, and then we have operational code or the operands and the respective T states. Now let's see the program in a step-by-step fashion. Now let us first consider MVIB00. Now what this means is store 00 immediately into the B register. So after the execution of this particular instruction, we will expect 00 to be in the register B. Now the next one, LXI E000. Now what does this mean? This again means load the HL pair with the content E0 and 00. We have to remember that whenever we encounter an instruction which is LXI H E000, it actually means loading HL pair with the content E0 and 00. Right now it is not meaning any memory location. It is only the content that is loaded into HL pair. Now here X means the HL pair or the pair that has been designated here. Now after the instruction is executed, H will contain E0, L will contain 00. Now let's move on to the next instruction. Now what is the meaning of this? This means move the content of memory into accumulator whose address is now in HL pair. That means whenever a microprocessor encounters an instruction which is having M in it, then by default it will look for the content of HL and that will be treated as the memory pointer. Now we can see that 49 was located across E000, which is transferred to the accumulator through this instruction. Now let's move on to the next one, where we are incrementing the content of HL by 1. So now HL will be having E0 and 01. That means it's presently holding this particular information into HL pair. Now let's go for addem. Now what is addem? The addem means the content of memory will be added to the accumulator and the result will be saved in accumulator and the flags will be affected. So now M is presently pointed by E001, which is loaded in HL, and 50 is added with the content of accumulator which was previously 49, and the result is reflected in accumulator itself, and the flags are also affected. Now let's move on to the next. Again we will increment the content of HL so that it points to the next location, and now we will check whether is there any carry or not. Now in this case, after addition we will not get any carry. Hence the instruction that says here is jump upon no carry. That means jump to the location labeled next if there is no carry. Since we will not be having any carry, it will skip this particular instruction and move to this instruction corresponding to the label next. Now move the content of accumulator into the memory. Now since the HL pair is presently having E002 in it, it will transfer the content of accumulator to the memory whose address is in HL pair. So E002 will now presently have the result. Now increment the content of HL, which is presently pointing to this particular location. Then again using the instruction move M, B, which means the content of B will be transferred to M and whose address is presently in the HL pair. So since the HL pair is presently having E003, the content of B will be transferred to this particular location, which will actually reflect the carry. Since in our example we didn't have any carry, the result will be 00, and next will be halt. So after the execution of this entire sequence, we will get the result in E002 and carry in E003. Hope you have understood the algorithm, the flowchart, and the assembly language program. Hope you will enjoy it. Thank you.